Many of my trips in Moonlight involve transiting the broad expanses of places like the Great Sandy Strait. So for me, an inboard is not a luxury but a necessity. When the wind fails, as it often can in this region, the currents are too strong to negotiate under oars, and the distances are too great. The existing installation has served me well over the life of the boat, but recently the motor has been getting very noisy and the shaft has started whipping around in a very disturbing manner. It wasn't until I started probing around that I realised just how bad the problem was. If you look closely, you can see the pillow block has detached itself from the keelson, so it's not providing any support for the shaft. So with the Christmas break coming on, there was a perfect window of time to steel myself to the task of getting the project underway. It's possible now to separate the noise from the shaft and the shaft bearing. Which you can hear that little grumble in there. So I'm going to replace this bearing here, which is the thrust bearing. You might have recalled a little while back I did a video on pulling the motor, inboard motor out of Moonlight and removing the shaft and the bearings because there was a lot of whip in the shaft, and I discovered a few problems as I started to pull that apart. So now I'm just going over the components and laying them out and preparing to reinstall them and to make it even better than it was when it was brand new. So starting with the motor. So the motor's is a Honda standing motor, often used on generators. A bit of work to do here, but nothing too serious. So the compression is absolutely fantastic after 25 years, considering it's also got a decompressor in there, and that's still producing heaps of compression. I'm going to take the rocker cover off and adjust the valves. They've been clattering a little bit, the motor's been a bit noisy. And there's a few little bits of rust to clean up here and there, but apart from that it's fine. The main thing was that there was a lot of whip in the shaft, and a lot of that energy was being transferred onto this main bearing here. And there is no sign of any leakage, the seal is perfect and the bearing feels fantastic. So fortunately nothing major to do on the motor at all. But the universal coupling itself is in absolutely fantastic condition, including the rubber insert itself. I will be checking on the alignment in case there's a little alignment issue here. Normally where we go onto the shaft, we put two grub screws in at 90 degrees to one another. If there's any slop at all here, that it evens it out and lines it up nicely. Whereas on the keyway there is only one grub screw, and I want to take that apart and clean it off just to make sure that it hasn't been knocked out of alignment there. The housing itself is also in fantastic condition, and so all I need to do is wire brush that and reinstall. The bearing itself, which was the source of the problem, so the pillow block bearing that takes all the thrust off the shaft, was a bit grumbly, and I can feel it there, just grumbling a little bit. It wasn't perfect from day one, I remember, and I always felt that maybe I had actually damaged the bearing putting it in. And so here's the new unit, and it's a 5/8 shaft as opposed to metric, and I was a bit concerned that I may not have been able to get a 5/8 bearing, but I was able to get one straight off the shelf. And so there it is, there's the replacement bearing, exactly the same as the original. Just want to keep an eye on these grub screws here. Hopefully they're high grade of stainless steel. Then we come to the stuffing box, and I've pulled one of the stuffing boxes apart, and the packing, the shaft packing that's in there had all collapsed and disappeared. Over time you can tighten them up and screw them down a bit. So this goes on the shaft, and then I'll wrap a bit of the packing, which is impregnated with a lubricant, and we'll wrap that round the shaft like so, and we compress it like so, and then turn the lock nut onto it. So there are two stuffing boxes, internal and external. This is the internal one. I also fitted a grease nipple to that back in the days when I built the thing, so that I could make sure that this internal stuffing box, which doesn't get any cooling effect from the water, is always guaranteed that it's kept friction free and no heat builds up in that. And then there's going to be a bit of work in this part. This is the pillow block itself. I was never happy with the design of this, and it had actually let go, so you can see there's no adhesion whatsoever here. Gradually the silicon bronze screws have corroded, and it was really just floating around there, not doing anything. So really the thrust was transferred directly to the main bearing on the motor. So these are the two studs where the housing sits, like so. And because the timber has moved over the years and the alignment is not perfect, so I'll have to put quite a bit of work into this. So I'm going to strip this back. I'm going to reshape it to create some sort of more pleasant curves on it and reduce some of the bulk where it's not needed, and then make sure that this is all cleaned up and properly epoxied onto the keelson. Then next comes the propeller, which is in pretty bad condition really. I hit some coral, but over the years it's had several bangs on it, but you can see there's a few nicks and scratches and dents there. Now the thing about this propeller is it came off a boat that was probably much larger than this one, and it was really overkill. When we first got this propeller, I was told by my mentor John that I could knock some of the pitch off the propeller. So I actually did that, because when I first put it in the water, it went along like a tugboat. Honestly, it was like this, even at low revs. So it's a bit of overkill. So I was going to build up the bronze propeller again. I'm not all that excited about trying to tap pitch off it, because it's still overpowered, because I'm concerned that the age of the bronze, it might even be a little bit brittle, and last thing I want to do is to break it. So what I decided to do instead is I'm just going to very carefully just pare it down a little bit and take all the nicks out at the edge, and it means that the diameter of the prop will be slightly smaller, and that might even slow it down a fraction more, because remember, if you saw that earlier video, it's a direct drive. There's no clutch, there's no gearbox. It's either on or off, and it's pretty well full speed from the time it fires up. So by reducing the diameter of the prop just a little bit, it might actually slow it down a little bit at lower revs. Again, we've got the two grub screws here, stainless steel grub screws, set at 90 degrees to one another, which guarantees that it centres itself on the shaft. And so the shaft itself is 5/8 inch shafting steel, so perfectly true, and I've checked it and it's as straight and true as the day it was made. And so I'll clean this up a little bit, just take a couple little burrs off the end, so that when I refit the stuffing box and refit the bearings, that they go on with a comfortable sliding fit there, rather than potentially doing some damage to the inside of the stuffing box bearings. Once the propeller is attached to the shaft using the grub screws, that propeller is not going to go anywhere, so it just tidies up things, that nice nylock stainless steel nut on the end. So that's the beginning of the project. I couldn't bring myself to dispose of this old piece of hewn pine, so I used a lot of epoxy to rebuild it. I've reworked the pillow block, done a lot of repairs there with araldite, which is a flexible kind of an epoxy, and I've reshaped it so there's a bit more of a pleasant curve there, reducing some of the weight in the timber where it wasn't needed. I also put, you can see some lines here, actually fitted a piece of aluminium across here, epoxied that into the block so that it'll take the load from the housing when that sits on there, like so, because the timber had compressed over time. When you're working with bearings and tolerances, when you've got timber, it's never going to be perfect. So that's ready to refit, and now I'm about to start working on the engine bed itself. It's just fabricated out of mild steel. I'm using Dulux Metal Shield Pressure Pack for convenience. Normally you'd struggle to get the needed build with spray packs, but this product is an exception. There's no primer required and it dries tough but still flexible. It's an experiment and time will tell if I made the right call. The motor was clattering a bit and quite noisy, so I needed to check the valve clearances. While I was at it, I regapped the spark plug. Turns out the tolerances were all correct to the manufacturer's specs after a lifetime of use, which says a lot for Honda engineering. This design is as old as the boat. Honda has not changed it much at all in 40 years. Finished preparing all the components to the drive shaft rebuild, and I've laid them all out in an exploded view so that you can see how they all fit together. Starting at the propeller end, there was nothing much to do here apart from take a couple of burrs off the shaft, but the propeller itself took quite a bit of work. I've pared it down a little bit so it's just a tiny bit smaller than it was before in diameter, because that was easier than rebuilding the bronze. I didn't know how bronze welding would affect the old bronze and I didn't want to break anything. So I tapped everything back into shape just very gently, filed off all the burrs and feathered the edge. The stuffing boxes themselves were in pretty good condition still, so there wasn't much to do there, apart from just remove the old jute packing and clean them up, give them a bit of a wire brush, and ready to put the new packing in. Next we have the thrust bearing itself, and the bearing was the thing that was creating most of the noise on the shaft. So this is a brand new bearing, and I've wire brushed the housing and ready to reassemble. So the pillow block itself was in pretty poor condition. There were places where the timber had been flogged out, and I've rebuilt it. I've built an aluminium strip in here to stop it from compressing when I bolt the housing for the bearing back on there. So that's now ready to go back in. I've wire brushed these and recoated them with epoxy paint, even though they hadn't rusted, and there's no deterioration at all, no pitting in the surface at all, which is testimony to the quality of the metal in those castings. The motor, again, very little needed doing there. I took the tappet cover off, checked the valves, and they were still as perfectly to spec. I sanded back the engine and recoated it with epoxy paint, and that's just improved the appearance a lot, but also protected it from a couple of little bits that were starting to rust there. The spark plug itself needed re-gapping, and honestly they're the only two things that I did to the engine. The coupling consists of two cast iron flanges and a rubber spider element, which performs well under compression and flexing. It's got a modular design that allows for simple fitting and easy maintenance, and the rubber element absorbs the shock loading and compensates for any minor misalignment of the shaft. For some reason, the bolt holes in the engine bed no longer lined up with the engine mounting holes. I made up a template and bored slightly oversized holes to allow for aligning the shafts. I was surprised at just how much things have moved around over time. Oil impregnated jute packing for the 5/8 stuffing boxes is still the same as it's been for hundreds of years, and it's easily acquired from any decent marine store. Once it's packed in there, the stuffing box can be reassembled and tightened just past finger tight. Don't overdo the tightening as I did the first time around, creating a build-up of heat. It just needs to be packed tight enough to stop any major leaks. A drip or two is a sign that you have it right, providing some cooling for the bearing. In this installation there is no stern tube, but the shaft hole is packed full of grease. After I've taken her out on a next trip, I'll inspect the stuffing boxes and just check if they need tightening down a little bit more. This is something that you need to do from time to time. This is the first of probably 20 or 30 times that I lifted the motor in and out in the process of getting it aligned. It's a very simple setup with just 2 bolts required to attach it and to detach it. The alignment of the stuffing boxes inside and outside the boat seemed to be pretty close to perfect. I used plenty of Sikaflex there to bed the stuffing boxes in. And I noticed that it was a bit firm when I gave it a rotation by hand, and I think that I had compacted the jute stuffing too much and was putting too much pressure on the shaft. After reshaping the pillow block, I ended up with a nice gap of about 8 millimeters between the block and the bearing housing, which made it very simple to machine a piece precisely the right thickness to get it lined up nicely. After measuring the exact angle and height that the motor installation needed to be at, I bored a couple of holes into the ends of the engine beds to the exact depth to get the angle that I wanted. Then I was able to plane down to the bottom of those holes that I'd bored and tapering it towards the aft section. The entire inside of the boat is due for a good scrape down sand and a repaint. Because I'm installing the motor over the top of this, I decided just to clean up this entire section here underneath the engine beds. I'm fitting up the bearing housing on the shaft here so that I can calculate the exact thickness that's required for a hardwood block that I'm going to place over the top of the pillow block. The jaw coupling itself is a brilliant piece of engineering that physically separates metal to metal contact. It allows for any minor misalignment there, and it stops sound transmission back into the shaft and into the hull. There's a bit of give and take required in getting it all aligned properly. You're dealing with timber that's moving between summer and winter as it picks up and gains moisture. At the moment we've got very high humidity here, so everything's swollen to its maximum size in all the wooden components. And then when the winter comes, the relative humidity is going to drop and all these timber components are going to shrink. So I need to keep an eye on it. I guess I could shim a few things later on if I needed to do that, but I think if I get a sort of a midline of tolerance, then it'll be fine. The metal engine bed, or the cradle that the engine itself is bolted to, is not perfectly engineered in itself, and you can see a bit of light underneath the straight edge there on the port side engine bed. At this point it really is an art and not a science. But you can see there that the shaft is not perfectly aligned, and there's quite a bit of work to do, many times lifting in and out and using feeler gauges to get everything at sort of a line of best fit is the best way I could describe it. Once that's done, time to paint the engine bed, and now the tolerances are getting closer. You can see that the housing has now been mounted on a hardwood block, and using feeler gauges just to check. I want to thank everybody that contributed to the conversation about how to fix the noisy drive shaft in Moonlight. There were lots of really good suggestions, and combined experience there has helped me to make some decisions. I'm just in the final stages of fitting up the drive shaft, and the interesting thing was there were a lot of alignment issues, and quite extreme in places where the timber had shrinked and moved and compacted as it was pounded over the years, and fastenings had let go, and it gave the appearance that it had maybe a bent shaft or a main drive bearing might have gone in the motor, but fortunately that was not in fact the case. The only component that had to be replaced was the thrust bearing. Things were quite badly out of alignment. So the challenge at first was to pull it all apart, and fortunately all of the grub screws that I installed there, stainless steel grub screws from 40 years ago, were running freely because I'd kept them very well greased and lubricated over the years, protected from any corrosion. Stuffing boxes were in perfect condition. They obviously needed to be repacked, and the alignment of the stuffing boxes was still pretty good. Fastened with. Here's the template that I made up to transfer the bolt holes from the bottom of the motor to the engine bed. I've created a bit of a field of operation with some drop sheets there because, as I mentioned, I've got to scrape out the entire inside of the boat and repaint it. But while I'm at this area, I thought I'd just make it look a bit tidier. I'm tightening down the housing for the thrust bearing with a couple of stainless steel coach screws. It's difficult to get a bolt through there because there's not enough room outside of the keelson, so I'm hoping that this will hold. I've used a lot of silicone there, and the alignment there is absolutely perfect as I'm pushing the shaft through. Here I'm testing the fit of the engine cradle without the engine attached. Makes it a bit easier just to check that it's all going to work. And that just slots in there nicely. You notice the right hand stud's a bit shorter. That's because of the fact that the head of the engine angles out in that direction. Now I've got the motor in place, I can begin to test the actual alignment in one of several different directions. I needed to tilt it forward just a fraction more, so I was able to put a couple of little washers under the aft engine mounting bolts, and then it was near enough to perfect. Like many of our fathers who were born during the Great Depression, mine was a cranky old bugger at times, and very difficult to get close to. In 60 years we never once spoke about anything that involved politics, religion or emotions, especially emotions. But he loved me dearly, and he gave me a love of timber and shared his delight in boats. He taught me how to grind the valves on his V8 Pontiac. He gave me a toy steam engine to play with, and fortunately he didn't see the day that I lit a fire and placed the boiler in the middle of it just to see what would happen. It exploded and I very nearly lost my eyesight. When the lawnmower reached its use-by, he gave me it to tinker with, and I'd sit for hours tuning the carby just to see how slowly I could make it run. This next section is for old farts who relish just to watch engines ticking over quietly and can do that for hours on end. Here's to our amazing dads that taught us to appreciate stuff like that.